and indicators of risk library for industrial network security. Convergence of operation technologies and IT has given attackers new opportunities for novel types of attack procedures. In the case of industrial environments, impacts go beyond information security because they can affect critical infrastructure and also disturb industrial processes and cause physical damage, such as to equipment or health, safety, and environment, and also incur very high costs. Security controls are not always straightforward to apply. For example, in patch management, you cannot apply a patch just when it becomes available. You usually will have to do it during scheduled maintenances, which are once every few months. And also, even then, there won't be feasible always because there's a lot of legacy systems involved in industrial environments. So it will be normal that certain level of risk is accepted. However, these risks need to be acknowledged and also need to be monitored as a compensating control. This paper is a complement of our previous work on a methodology for continuous risk management in industrial systems, in which we regard risk assessment as a continuous and data-driven process. In this context, we define indicator of risk as an observation that can modify probability estimation. Our research questions are: what information is needed in order to monitor security risks in industrial systems, and how can that information be derived from what you can actually measure? So it's widely accepted that risk quantification is done based on the probability and the impact. So indicators of risks are based on the awareness of factors that can influence in the probability of a cybersecurity related event. The indicator of risk library helps identify in these IORs and maps them to adversary techniques from the ICS MITRE attack framework. As indicators of risk can be very diverse from system to system because ICS have very particular environments in different industries, our work consists on a catalog of high-level overview of the indicators of risks. Then guidance is provided on the interpretation and how to implement each indicator of risk in particular. So the main contribution of our work is a model with common language for defining and sharing risk information and a basis to enable real-time risk monitoring and advocating for the integration between risk management and security operations. At this stage, our work is rather conceptual, but the indicator of risk library has a lot of potential to be useful as a resource to share knowledge among the ICS security community. The ICS matrix from the attack framework became available at the beginning of 2020, which led in the decision to base our indicator of risk library in this model. The reason for this is that it's a well-known framework which corresponds to a very rich knowledge base on TTPs, tactic, techniques, and procedures, and it's also based on community collaboration in which many security experts in ICS, which have been doing research and finding ICS specialized malware in the wild and studying the different procedures, have collaborated in this model. Other available models and the most typical for attack are the enterprise, the mobile, and the one we're basing this paper, which is the ICS model. So what is an indicator of risk? It is any detectable condition, the observation of which can alter the estimated probability of one or more possible threat events. So when they are observed, the risk of an attack attempt being performed in the present or immediate future increases. This is the merge of the concept of key risk indicator and indicator of compromise. Typically, an indicator of compromise that has a low degree of confidence will be dismissed because it produces too many false positives. However, it doesn't mean that this information cannot be valuable for risk analysis. So an indicator of risk will not be necessarily used to trigger security alerts, but to raise awareness on an increased risk level. This can be useful for organizations to continuously assess their security posture and act proactively to counteract cybersecurity threats. So the objective of an indicator of risks is to be an indication of risk exposure rather than to be used as detection. So they are associated with a high probability on an unwanted event, and hence they are not deterministic. However, a combination of indicators of risk can provide more certainty about the possibility of an event. In the right-hand side, you can see a Venn diagram in which we regard indicators of compromise as a subset of indicators of risks. The difference is that when you move towards indicators of compromise or even security alerts, you're having indicators that are more deterministic, whereas that pure indicator of risk is more probabilistic. There is a challenge also in measuring the effectiveness of indicators of risks, since now the concept of false positive is not applicable anymore. So related work, well, we based our literature review in 3 types of work. The first is continuous risk assessment. The second is dynamic risk calculations methods. And the last is security detection tooling and methods in industrial control systems. As far as our knowledge, not work has been previously published that is focused on providing a structured knowledge base for identifying cyber risk indicators for ICS. So how did we build the indicator of risk library based on the TAC framework? Well, we use as a reference the Purdue model, which shows the different levels of an industrial control system. And we relate different indicators of risk groups, numbered with prefix 0 to 7. Indicators of risk include observations from hosts, endpoints, workstations, HMIs, IT and OT network monitoring, and also field devices, which includes data from sensors. So each one of these 8 groups refers to a level of the system where the data origins or could be observed, which is not necessarily the same level. I can observe something on a field device in a workstation, for instance. And group 0 will have the characteristic that it refers to vulnerabilities or preconditions. For instance, if I enable a remote connection temporarily, I will increase during that period of time my risk exposure. Then groups 1 to 7 refer mostly to threats. So when the ICS attack matrix became available, we already had a list of indicators of risks. So we started reviewing techniques from the framework and identifying which indicators of risks were applicable to the technique. Then we identify new indicators of risk that could be added to the list and refine the definitions. For example, technique 868, detect operating mode. This is the entry that is available in the TAC knowledge base, in which you have a description, data sources, assets, also procedures examples, in this case Triton. And also you can read further on the procedures that use this technique and how they work. So from this, we have this list of indicators of risk. For example, indicator 117, suspicious OPC commands. OPC is a protocol that runs in Windows, which is widely used in industrial control systems to communicate with industrial protocols. So if we can detect commands that are querying the operating mode, then we can infer that we have a higher risk of this technique being performed. We also have the explanation for each indicator of risk in a generic way, in a tab that's called the IOR definitions. So this is just an extract with 4 examples in which each indicator of risks is defined with a rationale that explaining why we consider this an indicator of risk in the first place, observations, how we can measure or observe or detect this condition, examples, some scenarios where this can be observed, and then the list of related techniques. And then for each related technique, we have also the list of indicators of risk with the specific explanation to that technique. So how do we use the indicator of risk library for continuous risk monitoring? Well, first we need to define the techniques that are within the scope of our risk assessment. Second, we look at the indicators of risk that are applicable to those techniques in the library. And we translate these generic indicators of risk in more detailed use cases that can be applicable to the specific ICS context in which we're doing the risk monitoring. Then we define which of them are feasible to be monitoring and how, given the available detection tooling and logs in the organization. And finally, we adjust the degree of influence of each indicator of risk technique pair, which is an indication of the conditional probability between the observation of the indicator of risk and the probability that the technique is or will be executed. For example, in our continuous risk assessment approach, we base our work on Bayesian networks, for which we use the indicator of risk library to do a Bayesian network template based on it. So in this diagram, you can see the 11 tactics from the ICS attack matrix. Each one of these corresponds to a submodel. So if I click on it, I will see another network with all the techniques that relate to that tactic. In this case, we have the example of impaired process control tactic. So then if I click in one of the techniques, then I have the nodes of each indicator of risk that has an influence on the probability of this technique. So here's an example of a use case we develop. So this diagram is for the initial access tactic, which in each node that corresponds to a technique or a security event, we can see the different probabilities. So how did we validate our indicator of risk library? As I already said, this work has been rather high level and conceptual. So we look into different references in which use cases were done using different detection tools and practical proof of concepts in industrial control system settings. Examples of these tools which are specialized for ICS are Silent Defense or SecRS. So we match the different use cases with our indicators of risks, which had a coverage of 39% of the library. For the other indicators of risks, we infer the feasibility based on the vendor information of different detection tools and also in known SIM capabilities. And also it's important to consider that a huge proportion of the indicators of risk, especially from the first 5 levels, are based on inputs commonly used in security monitoring. So for our future work, one of the important things is the maintenance of the library, so improve the current descriptions and examples, add more indicators of risk, cover more techniques, also develop structured guidelines to generate indicators of risk in particular contexts, get more feedback and contribution. This is part of my PhD research, so a work like this would be a lot more rich if it was, as in the case of the attack framework, based on community work, for which another future work idea is engaging with Mitre. I have already presented twice in the Mitre European workshop with the idea of sharing this and promoting the idea of the indicators of risk based on attack. Also do more case studies and develop an standard format to exchange indicator of risk information. Finally, as I said, there is a big challenge on assessing the efficacy of the indicators of risks. So it needs to be developed actually a method that could allow assessing and measuring this efficacy. Conclusions. The indicator of risk library systematizes observable conditions that are indicative of an elevated level of security risk and provide guidance on how to detect these observable conditions. The indicator of risk concept is in alignment of emerging recommendations, which are calling for security detection based also on behavioral models rather than only signature-based indicators. This as a matter of time constraints, we didn't go in a lot of details, but several indicators of risk, particularly the ones of the group of field devices and sensors data, are based on anomaly and misbehavior detection models. So some of the uses and advantages of the indicator of risk library is it can allow creation of templates and playbooks for security risk monitoring. Also, it promotes risk-based security monitoring and has the potential for use in forensics, as it provides a common language for documentation and analysis. Also, it allows prioritization of security investment, since it allows gathering data from the most frequently observed threats, which can allow allocating investments in the security controls with the highest cost-benefit rate. Thank you for listening. Please let me know if you have any questions.